Miriam, I won't be able to listen if you talk anything. So if there's anything, you have to drop a message in the chat because I don't have a speaker now. I connected this to the mic portal, so I want to get a one with both mic and speaker. Okay, a sphere M attached to a thread is whirled in a horizontal circle at a constant speed as shown in the figure. The forces acting on the sphere observed by a person who is at test in the laboratory are best represented by. Okay, so you have this. A sphere of M attached to a thread is whirled in a circle at a constant speed as shown in the figure. The forces acting on the sphere observed by a person who is at rest in the laboratory represented by. Okay. So what are the forces acting on this? It's weight downward, mg, and then tension here, T. Okay. So we have second one. Okay. Now some students may mark this one also as the centrifugal force. But actually that centrifugal force is provided by the component of the tension. Okay. Question number 43. A PN junction is connected to a battery as shown in the figure. When light is shown on the junction, electron hole pairs are created due to the absorption of photons. The current in the circuit produced by the incident light is okay. Due to the electrons moving in the direction of N to P and holes moving in the opposite direction. Okay. So you want to select the correct answer. The current in the circuit produced by the incident light is okay. A PN junction is connected to a battery as shown in the figure. When a light is shown on the junction, electron hole pairs are created due to the absorption of photons. The current in the circuit produced by the incident light is. So the question, the option 5 we can due to holes moving from N to P only, wrong. Due to electrons moving from P to N only, wrong. Okay. So either it's 1 or 2. Okay. Due to electrons moving in the direction into P and holes moving in the direction opposite direction. Okay. So it's actually we want to consider where the electrons are moving and the holes are moving. Okay. So now here we have the PN junction. So this P type means the majority carriers are holes. And N type means the majority carriers are electrons. Okay. When there is a light is incident, what will happen? There will be pair production, and a hole and an electron will be created. Okay. The atom will absorb the energy and release an electron. That electron becomes free. Okay. So here battery is connected in this direction. So it is forward bias or reverse bias? Reverse bias, no? So reverse bias. So the first thing you have to understand, it's reverse bias. So therefore the normal current doesn't occur. Okay. So there will be only due to this potential and then depletion region slightly increase. Okay. There will be leak current. That is actually due to this pair production. Okay. So therefore, if I consider the electric field direction, so this side is plus, this side is minus. Field is always means plus to minus. This is the field direction. Okay. So electrons will experience this direction P to N. Okay. Holes will be N to P. I say holes. H. No, you don't think that. You just consider any other place. There will be a pair production. Electron that created a hole will move in the direction of the field, and then electron will move opposite to the field. So therefore, here uh, electrons moving in the direction P to N. So second one is the correct answer. Okay. Okay. Question number 44. A thick wire A and a thin wire B made of same material are connected to a battery as shown in the figure. The length of the two wires are same. Consider the following statements. Statement A, both A and B have the same resistance. Is it true or false? False, right? Because resistance is given by rho L over A. For both wires, rho is constant, L is constant, but A is changing. A change, R is changing, right? Okay, so therefore resistance of B is large. Okay. To understand this resistance, you can take an analogy of running a race. Okay, there are three factors. Okay, first one is area. යන්න පුළුවන් තියෙන cross section එක. So if you have, let's consider 10, you and another 9 of your friends, including 10 friends, running a race. හරිද? ඉස්සෙල්ලාම 10 දිනාටම track 10ක් තියෙනවා. That is area is large. Now the track is reduced to only 4. Then resistance will increase or hindrance will increase or decrease. If you decrease the area, resistance will increase. Similarly, L 100 meter දුවන්න ලේසිද 400 meter දුවන්න ලේසිද 100 meter දුවන්න ලේසි. ඒතකොට 400 meter දුවන්න අමාරුයි. ඒතකොට length එක වැඩි වෙනකොට මොකද්ද? resistance එක වැඩි. Likewise rho මේක හොඳට කාපට් දාලා තියෙනවා. අනිත් එකේ මේ ගල් ගොරළු මේ කැඩිච්ච glass ඒවා දාලා තියෙනවා. මේ කෝකෙද දුවන්න පුළුවන්. කාපට් දාපු එක. So the rho also depends. Okay, so that's the best analogy you can consider when the resistance and related to rho L and A. So if you decrease the area, resistance will increase. So B has a small a cross section, so the resistance of B is large than that of A. So the statement A is false. Drift velocity of electrons in A is smaller than that in B. Drift velocity. So drift velocity is given by I equals N A N A E V D. So the drift velocity V D is equals to I divided by N A over E. Okay. So now for both A and B, I is same or different? No, same. Both same. Okay, for these two same, and charge of the electron will be same. And then now this is electrons per unit volume. So that is also constant, same material. So this is also same. So if A is increase means drift velocity decreases, no? Sorry? No, this is per unit volume. Per unit volume. That means, for example, per centimeter cube. If you take the same material, doesn't matter if you whatever the shape you make, that this is same. Okay. N is same for both. So here A is the cross section, no? Cross section of the wire. NA, E, V. So if you increase the cross section, this velocity will decrease. So therefore, drift velocity of electrons in A is smaller than that in B. A is small in drift velocity is small in A. Drift velocity of electrons in A is smaller than that in B. So B statement is right. Free electrons density in A and B are different. That is wrong. Both are same because they are made of same material. So C is wrong. So therefore only B is true. Second one. Only B is true. Since both are made of the same materials, the electron densities are same.
Okay, for parallel connectivity, but then drift velocity is also different, right? So
Parallel
the I is also different, right?
Yeah, then I will be different. Parallel connectivity. In that case, yeah. Since a series, the same current is only flowing. Question number 45. Okay, the figure shows force extension graph for a rubber band. Consider the following statements. Okay. A. The rubber band does not return to its original length after stretching. Is it true or false? True. Because you can see මේ loop එකට වචනයක් කියනවා. It's not there in your syllabus. Ice loop මොකක් හරි වලින් මේ loop එකට. So here we stretch, goes there, and then after it comes back. That means it doesn't come back to original length after stress is released. Even in the zero stress, we have some extension. So therefore, statement A, the rubber band does not return to its original length after stretching. That is true. A is true. B, the magnitude of the total work done during the increase of the length is less than the magnitude of total work done during the decrease of length. The magnitude of total work done during the increase of length is less than the magnitude of the total work done during the decrease of the length. False. Yeah, so B is false. Because work done is the area under the curve. So make area to ready, make area to vada. Okay. There is some relation, not directly. Now this is a stress versus strain graph. So that is not directly with the work done, but the area is proportional to work done. Okay. Because if you consider the energy per unit volume is stress times strain. Half. Okay, so you have a proportion here with the area. Okay. This is stress and strain. So the area under the curve gives something like energy per unit volume. Alright, so B is wrong. C, heat can be generated in this process. Is it true or false? Yes. Because some the excess energy different because somehow it has going out. Okay. So it has to be a heat or yeah. Okay, so only A and B, A and C is true. Fourth one. Question number 46. The filament of 100-watt bulb takes 200 milliseconds to reach to full brightness when the bulb is connected across a constant voltage supply of 230 volts. Consider the following statements. The 100-watt bulb takes 200 milliseconds to reach its full brightness. So we have a bulb. It's 100 volt. So that means maximum power output is P max equals 100 watt. Okay. It takes 200 milliseconds to reach its full brightness when the bulb is connected to constant voltage supply 230. So Okay, so 230 volt voltage plus this. Okay, during the 200 milliseconds period, the resistance of filament increases. The statement A, true or false? True. That is true. Because when it give heat, the filament heat up along with the resistance will increase. B, during 200 millisecond period, power drawn from the supply decreased to 100 watt starting from higher value. Okay, statement B, uh, during the 200 milliseconds period, power drawn from the supply. Power drawn from the supply. Can you make in any power? You have to consider the power of the supply. We will say here the power supply. Okay. Power drawn from the supply decreases to 100 watt starting from a higher value. Higher value. So here the power output is 100 watt. Let's say there is a small power heating in the wires. Actually, those things can be considered starting from higher value. Let's move on to the statement C. Filament emits energy in the form of electromagnetic radiation. Filament emits energy in the form of electromagnetic radiation. Yeah, that is true. The heat and light both are electromagnetic radiation. Okay. So we have A is true, C is true. The first one comes.
3 or 5.
So it can be 3 or 5. Either B is true or not true. Okay. So then we'll begin during the 200 milliseconds period. Okay. Then make her power is P equals VI 230. When the power increases, output power increases, resistance increase, the current in the circuit will decrease. So current in the circuit decrease means the output energy of this will decreases. So therefore B is false. Okay. The during drawn from the supply decreases to 100. No, it says decreases. Yeah, so it's correct. Decrease is correct, but it is decreased from higher value to 100 or it's or goes less than 100. Whatever. Make a maximum power output again of 230 watt current. What is the power? What is the voltage across this? P equals VI. Bulbs power output 100 watts. Okay. Battery dhammagaman. We get the maximum current in the circuit, and then current decreases. Okay. So let's say it saturates. When it saturates, then 100 watt maximum power. So then it decreases to 100 watt. So initially resistance is okay. The filament of 100 watt bulb takes 200 milliseconds to reach its full brightness. Okay, so the brightness power becomes maximum after 200 milliseconds. So that is the full brightness, reach 100 watt. So then if you consider no any heat dissipation through this, so then the power given out from the battery also 100 watt finally. But we know initially the resistance is large, it is small. As this heat up resistance increases means current decreases. So consider the B statement is true. So therefore, uh, all A, B, C are true. Do we have a scheme for that question?
Answer is only N.
Only A and C. So the third one. During 200 minutes power drawn from the supply decreases 100 watt starting from a higher value. Okay. Yes. Now, then make a maximum power output then 200 milliseconds. When it takes 200 milliseconds time to give out the maximum power output of 100 watts. Okay. So that means before that, it is giving out a less power, no? Increasing to Vmax. So whatever the power going out from here is given from the battery now. So if there's any output power out in the wires and all, so then methane yana pramani methane endo. Then it has to be the same starting from less value increasing to 100 watts. You understand? And make it takes 200 milliseconds to get to the maximum power. So that means initially starting from a low increase. So the same power output is given by the battery. You had to consider the energy conservation. මෙතනින් යන ප්‍රමාණයට මෙතනින් දෙන්නේ. එතකොට what happens? This starting from a less value increases to maximum of 100 watts. So therefore B is okay. So only A and C are true. Third one. You have covered the syllabus, right? Matter and radiation. Mechanical properties of matter. Those two units you had. Apart from that, all. What about you? Magnetic electricity you had to do. You 25 batch. 25, right? Okay, so still did magnetic. Okay. And matter you have electricity, magnetism, matter and radiation. Properties of matter done. For you, all okay, no?
Diodes, but diodes.
Electronics padati. Digital electronics done.
Using circuit to build the logic gate.
ඒකත් පොඩි දෙයක් තමයි.
But logic gates කරා transistors කරා
අර circuit හදන එක ඒක අර oral IT knowledge. Okay. ඒක කරන්න පුළුවන්. ඒ oral IT එක. Okay. Right. 47. A thin uniform wire PQ carrying a current I could be held without any mechanical support above an infinitely long horizontal wire RS carrying the same current I. If the mass per unit length of the wire PQ is M, the equilibrium height H of PQ above RS is given by. Okay.
I also haven't done a bit of matter and radiation.
Matter and radiation.
Carbon dating and
කරන්න තියෙනවා.
Carbon dating will bind nucleotides and binding energy.
ඒක 10 ඉවර කරන්න පුළුවන්. භාගයක් යන අපි ස්ටාර්ට් කරන්න. අද ගිහලා කරන්න වෙනවා. All right. Carbon dating is same thing as the T-half. We know the T-half theory. Carbon dating can be done. All right. So we have two big wires. This one carrying a current I in this direction, and this one carrying current I in this direction. Okay, and then the height difference is H. Okay. Uniform wire PQ carrying current I could be held without mechanical support in fact. So right? So here what we have to consider is this weight in G is equals to the magnetic force. Right? If M uh, if gravity G equals to Fm. Okay. So then first we want to find the Fm, right? So the Fm is actually uh, is equals to F equals nu I1 I2 over nu 1 I1 I2 over N5 or something. 2 5. All right.
Also, I1 I2 into Ls. F is
Yeah, we will
BIA.
derive. But make it there is a mutual attraction force if the both are moving in the same direction. Repulsion if the current is moving in the opposite direction. So then you derive this. You have to actually derive and you memorize this formula. But you can't straight away using the essay paper. Okay. So the magnetic force P equals B I L. Okay, and B is equal to nu I over 2 5. Okay, then I can substitute here F equals mu naught and F equals BIL. දාලා තියෙන්නේ මෙයා මත එතන මෙයාගේ කරන්ට් එක I මෙයාගේ කරන්ට් එක මේකේ කරන්ට් මෙයා නිසා I හරිද? එතකොට මෙතන දෙකම I හින්දා no issues. New naught මම මේක I1 I2 ඊට පස්සේ මේක කරන්න. So that I'm giving addition. So now this one is VI1L. Okay, in this one magnetic field here produced due to the current this. Okay, so then you have B equals is this one nu naught. Yeah, magnetic fluxes. Yeah, then make a current magnetic field a magnetic field like a strength like a B. The magnetic field strength B, and it is given by this relation. Okay, so yeah, and then due to this magnetic, this creates a magnetic field, and then current going on this, and in a magnetic field, then it will experience the force. Yeah, the force is the stand rule. So for this, you have to use the right hand rule. No? Magnetic field coming out of the page. So then you can use left hand rule. Magnetic field, and current. Now this is the current. Current, magnetic field, force. So the current, magnetic field, current එක මේ පැත්තේ magnetic field එක මේ පැත්තේ ඒතර force එක උඩට. Current මේක current මේක magnetic field ඒතර මේක force. Okay. So you get the force. And same argument you can do for this. Then equal here also you get a force here down. Okay. Yeah. By the way, here we have to consider the weight. Yeah. So make a weight take a downward now. Wait. Hold on. The uniform PQ carrying current could be held without any mechanical support. Long horizontal wire RS. If the above an infinite long horizontal wire RS carrying the same current. So we have to consider this as being held by a support, right? If the mass per unit length of wire PQ is same, equilibrium height of it. So then here we have B naught I2 to phi R is into I1L. Okay. So then Fp equals to nu naught I1 I2 L over 2 phi R. This formula you should remember so that you can easily use. Now, if I already know this, then I shouldn't have spending time for deriving this. Okay. All right. So then we have we consider L length. So we consider L length. So the here mass per unit length is given m. Sorry, this I2 is here. This current in this one. But in this problem, actually I1 and I2 are same. Okay. Now here actually this Fm you can find. This is what I'm finding here. Okay. Right. Okay. So that is given by this. And then if this is in equilibrium, this Fm is equals to mg. So Fm equals Fg. So Fm I can write mu naught I1. So now I1, I2. So mu naught I squared L over 2 phi H. R is equals to H. Mg is M. The mass per unit length is M. The mass in L length is ml G. So L and L cancel. So therefore, let's do the cross multiplication. Mu naught I squared is equals to mg 2 phi H. Therefore, H equals mu naught I squared over 2 phi mg. Do we have such answer? Yeah, third one. Yeah, wait. L is the length. This is because m is the mass per unit length. For unit length, mass is m. Therefore, L length mass will be ml. So the total mass times g ml g. The third one is the answer. Okay. 48. A well-lagged Y-shaped structure made of copper has three identical limbs. Free ends of two of the limbs are connected to a metal block which is maintained at temperature T1, while the free end of the third limb is maintained at a temperature T0. The steady state temperature of the junction T of the structure is. Okay, so we want to find the temperature T. Here the temperature T0 and here temperature T1. I consider temperature T as T. Okay, and they are saying they are well lagged and made of copper, three thin identical plates, so same length L, L, L. Okay. Okay, so here we can write the heat conduction equation. The heat flow rate Q dot is equals to Ka delta theta over delta L. So Ka delta theta over delta. That's the heat conduction equation, the rate of heat flow. So then first I can, so they are in steady rate. So therefore the total heat, let's say here Q, then here it will divide by
അതൊക്കെ തെങ്ങിന്
T1.
നമുക്ക്
Oh, right. Block which is maintained at temperature T1 while the free end of the prelims, the steady state temperature of the Cohombial, we get the same. So I consider here temperature is large, K is low. Okay. So then the temperature flows from here Q. I consider 2Q. So this will be Q, and this will be Q. Okay. The methane is samphonic methane and on in the 2Q, that will be Q. So then first I can use for this one heat flow rate to Q is equals to Ka times temperature. Difference is I consider this one is higher temperature, this lower temperature. So we have T naught minus T divided by L. Okay, and then we can put the equation for one of these. So you get Ku equals Ka T1 minus T minus T1 over L. Okay, so then I can substitute this here. Then 2 times Ka T minus T1 over L plus Ka T naught minus T1 over L. Ka cancel, Ka cancel. Expand the brackets to T minus 2T1 is equals T naught. I think I made a mistake here. T naught minus T. T naught minus T. So I want to subject T. If I take that to this side, 3T equals T naught plus 2T1. Then make it a them up with an temperature T naught minus T, and then here T minus T1. Okay, and then T minus T1, T naught T, okay, 2T minus 2T1. Now so the T is equals to T naught plus 2T1 over 3. The fifth one. Here, because the temperature difference T naught minus T here. Here the temperature difference T minus T1. Okay. Miriam, still the voice is echoing, or is it clear now? Is it clear? So there are certain things that you have to do and try. නේද? දැන් මෙන්න මේ වගේ එකක් තිබ්බනම් ෆෝමියුලා එක මෙහෙම එන්නේ. Okay. ඒකම දැන් what we have three rods. What we have three rods. So the identical rods. Okay. Temperature is P1. Now we have three rods. Then what will be the relation will be? Can you try? Then only the difference. No need to draw everything. Only here you have to replace 3. Yeah. T minus P1. Here I am considering the temperature flow, heat is flowing this direction. Okay, so here the temperature is high, and then here less than that, and this temperature is less than that. So here T naught minus T and T minus T1. T naught minus T, T minus T1. Okay. If we have 3 rods, then this 2 becomes 3. So මෙතන 3 දැම්ම නම් 3යි T minus T1 is equals T naught minus T. So then we have 3T minus 3T1 equals T naught minus T. So we want to subject this. Therefore, T is equals to, sorry. Make a T minus T1, T naught minus T, T naught minus T. T minus 3T1, T naught minus T. So we take this T to this side, then it becomes 4T equals T naught plus 3T1. So therefore T equals T naught plus 3T1 over 4. Okay. So the temperature will be, you can see a pattern. This T naught is constant. This temperature is constant. And then here 3 out of 4, 4 out of this, like that you can get a pattern. Okay. Anyway. This type of questions you have in past paper, you have in essay also. Okay. Okay, and then question number 49. The oxygen molecule has 16 times the mass of hydrogen molecule. The oxygen molecule has 16 times the mass of hydrogen molecule. At room temperature, the ratio of the mean square speed of oxygen molecules divided by root mean square speed of hydrogen molecule is. Okay. So we know that root mean square the square mean root velocity is equals to gamma RT over M square root, right? Hold on. Root mean square speed oxygen. No, that's 3RT over M. That is for the sound. Okay. 3RT over M. So therefore, we can see it's proportional to this at same temperature, at room temperature. So this is inverse proportional to them. So therefore, we want to take root mean square speed of oxygen molecules. So oxygen is 32 times the hydrogen. Sorry, 16 times the hydrogen. 1 over 16 square root. So 1 over 4 will be the answer. Okay. Because here we want to take the oxygen, the hydrogen. So oxygen is 16, hydrogen 1. So 1 over 16 square root is 1 over 4. Okay. 50th question. The figure shows the path of a particle x of charge q moving in the vicinity of another fixed particle of charge capital Q. Variation of the speed v of the particle x with the distance d traveled from A along the path AB is best represented by. Okay. So when it is at here, the distance is larger. So the force is small. But when it comes closer, the force increases. So therefore acceleration also increases, velocity also increases. So the velocity increases, okay, rapidly. That means not in a constant way, because acceleration also increases. Okay, if it's constant acceleration, it has a constant gradient, but acceleration also increases, so there will be a curve. Okay, so you want to see which is out of the fifth, which is the correct one. So we have 5 options: 1, 2, 3, 4, 5. So out of that, clearly the 2 won't come. That's constant velocity. Okay, and I think this one is 1. Okay, this one is 2. Third one is this. Okay, and then 4 and 5 are confusing. Which is 4? 4 supposed to be, I think, this. The other one, the steeper one. 5 is this one. Okay. Okay. So the fifth one also won't come. That is also not there. 2 also no. Okay. So out of this, first what we have, velocity increases. Velocity has to increase to no, both positive charge. So therefore velocity decreases. Velocity decreases to a minimum value and then it increases. Okay, so the answer is either 3 or 4. Either 3 or 4. In fourth one, the velocity becomes 0, right? So here we want to draw the distance traveled. Here speed, no. Speed is the magnitude of the velocity. Speed is the magnitude of the velocity. Thank you. Speed is the magnitude of the velocity. Okay, so you can see there is always a component of velocity. So therefore, speed cannot be 0. So therefore, the answer is the not the fourth, third one. Okay. #51. Crushed ice pieces at 0 Celsius are kept inside a thermally insulated closed container. Heat is applied to container at a constant rate and pressure inside the container is kept constant. The variation of temperature inside the container with time is best represented by. Okay. So it is 0 Celsius ice. So if you give heat, what happens? First, the ice melts. So initially, the constant temperature remains constant. By considering that, we can ignore fifth one. 1, 2, 3, 4, 5. Fine. Because first we have a constant temperature, the ice is melting. The temperature inside the container. So you can see in all the ice is actually becomes water and becomes what it's getting boiled also. Okay, so this you have to consider the boiling time and compare the melting time. Which one has a large this one L value? L is latent heat of fusion and latent heat of fusion for ice melting, and the latent heat of vaporization. Latent heat of vaporization. So out of these two, tell me which one has the large value. This one. Can you explain me the reason why? There might be, you might get a question in exam. Latent heat of fusion era, latent heat of vaporization very. Why? Yeah, make a, you have to the bond length එක පොඩ්ඩක් increase. Make a bond length එක ගොඩක් වැඩි වෙනවා. Bond එක you have to break the bond. Not only that, you have to do work against the pressure of the atmosphere. So therefore, this one has a large value. The maker ගොඩක් energy එකක් කියවන හින්දා මේකට ගත වෙන කාලය වැඩි melting එකට වඩා. Right? So you have to consider that. We can ignore third one. So we have 1, 2, and 4. Yeah, fifth one we already removed because there is no time given for the melting. Okay, so now we have the candidates 1, 2, and 4. Let's compare 1, 2, and 4. What are the difference? So after 100, okay. So here you have heat supplied to container at constant rate, pressure in container at a constant rate, and pressure inside the container is kept constant. The variation of the temperature inside the container with time is best represented by container pressure is constant. Okay, so make a vaporize when you got a pressure constant when the then container ke වතුර තියලා yeah vaporize now it's vaporizing and then temperature is increasing. The all the heat is given to this okay. Now we have to consider PV equals nRT. This is constant volume constant. If T and pressure constant, temperature has to be constant. Yeah, now if the water vaporize, it will no, it gives more pressure to the container. No? The with time is best represented by. Okay, now we can compare 1 and 2 for example. Okay, then water के temperature වැඩි කරන්න ලේසිද heat air එකේ temperature වැඩි කරන්න ලේසිද? It's easy to heat up solids or gases. Gases, because they have all this heat capacity. So then by comparing those two, we can ignore question the 1 and 2. If we compare, the 1 is best option because the temperature increases more sooner. So then we have the candidates 1 and 4. Yeah, 4 it says I completely keep melting. So I think the answer is the first one. The answer is, what is the answer? 1. Okay, so yeah, answer is the first one. Okay, 52. Uniform metal cylinder of mass M hangs from a spring balance A and is lowered slowly and steadily into a water container of mass capital M. where m is greater than simple m. Uniform metal center of mass simply hangs from a spin current safe and is lowered slowly into a water container of mass capital M until it rests totally submerged on the bottom of the container. The container is placed on the pan of weighting scale B as shown in the figure. The variation of readings of A and B with time are best represented by. Okay. So we have 1, 2, 3, 4, 5 options. The first one not true, because when you immerse the water inside the uh, object inside the water, the reading in the A scale will decrease. Okay, so the scale of A comes here and it will has to decrease. So by considering that fact, we can ignore 1, 4, and 5 is also not a good not correct. It may B is continuously increasing, A is decreasing. So then we have 2 and 3. 2 and 3. Okay. Now here one more thing. The sum of the values of A and B has to be constant. Okay. So, okay. So here in second one, you have sudden drop. Here no. So A is going to be 0 if this touch. Yeah. When this touch the bottom, it says no. It totally rests totally submerged on the bottom of the container. Then the answer is second one. Okay. The tension of the spring will be 0. By the way, if you in this graph, any point in this graph, any point, if you draw a line, you make anything. If you add this value and this value, gives the total weight. Here also gives the total weight. මෙතන අඩු වෙන ප්‍රමාණයට මෙතන වැඩි වෙන්නේ gives the total weight. Okay. 53. A metal block is suspended at rest below the surface of water in a tank as shown in the figure. When the block is released, it falls to the bottom of the tank. Consider the following statements. Statement A: the block gradually loses its gravitational potential energy as it falls. Yeah, if it goes down, the gravitational potential energy decreases. Right? B: although the height of the water level does not change, the water gains gravitational potential energy. That is also true. Okay, I'll explain you that. See, if water was not present, the kinetic energy of the block at the point A would be less than at A when water was present. Now it has to be greater, no? වතුර නැත්තම් හයියෙන් කියලා වදිනවා. So kinetic energy will be greater. So A and B are only true, no? Do you understand the statement B? Make A. Initially the block is here. Initially block is here, that means no water. And then if the block, we move the block here, it's like we taking this amount of water and keeping here. So that gravitational potential energy of the entire water is slightly increases. Okay. Height of the entire water remains same, but initially the methane block එකේ තිබ්බේ. ඒතර මෙතන වතුර නැහැ. ඒතර block එකේ මෙතනට ගෙනාවම ඒක හරියට මෙතන තියෙන වතුර ටික අරන් මම මෙතනට ගෙනාවා. එතකොට මොකද වෙන්නේ? මෙතන තියෙන මේ අදාළ කොටසේ gravitational potential energy එක මෙතනට එනකොට වැඩි. So gravitational potential of the energy of the entire water is increases even though height doesn't change. Okay. Okay, 54. The transformer shown in the figure has N1 turns in the primary and N2 turns in the secondary. Primary ke N1 turns secondary ke N2 turns Root mean square voltages across primary and secondary are V1 and V2 respectively. The correct statement regarding the transformer is V1, the root mean square voltages across primary and secondary are V1 and V2. Vs Vp over Np is equals to Vs over N. Is this correct? Vp over Vs equals Np over Ns. Okay. So Vp over Np equals Vs over Ns. Mega. So here they are saying root means square voltage. Root mean Vrms is equals to 1 over root 2 times V peak voltage, right? Peak voltage again. Okay, let's consider V1 N1 equals V2 N2. Is it correct? Wrong, no? Statement 1 is wrong. The correct statement regarding the transformer. So 1, 2, 3, 4. 1 is wrong. If the AC source is replaced by battery with the same voltage V2, replaced by a battery with the same voltage V2, V2 remains the same. No, V2 will be 0. Hey, battery can DC current එක. DC current එක දැම්මම මේ පැත්තේ මේකක් වෙන්නේ නැහැ. මෙතන voltage එක අඩු වැඩි වෙන්න ඕනේ. ඒකවල තමයි මේකේ magnetic field එක අඩු වැඩි වෙලා current එකක් generate. So therefore that is wrong. Okay. You got it? Yeah, so you are replacing this by a battery. Battery is a DC current, direct current. Direct current again transformer එකේ voltage එක හැපෙද්දී generate කරන්න බෑනේ. So the principle of transformer is මෙතන voltage එක අඩු වැඩි වෙනකොට according to the Lenz's law magnetic field and the induced EMF will be created. So that induced EMF also අඩු වැඩි වෙනවා මේකේ. ඒතකොට ඒකේ අඩු වැඩි වෙනකොට according to the Lenz's law again there will be the current will be produced. Okay. So DC and V2 value will be 0. Okay. I mean maybe if this can conduct this part, if it's conduct the current, then maybe it will be same value of the input. When the secondary is connected to a load, the current in the secondary will not depend on the load. Current in the secondary, it depends on the load. So 3 also wrong. Okay. 4. The only reason why the core becomes warm after some time is the heat generated due to the resistance of the coils. The only reason why the core becomes warm after sometimes is the heat generated due to the resistance of the coils. No, there is eddy current also. ඒ eddy current එක අඩු කරන්න තමයි අර transformer එකේ අර මෙහෙම දාලා තියෙන්නේ. If the core is removed, V2 will decrease. O is also wrong. If the core is removed, V2 will decrease. V2 will decrease. Yeah. So OE we use for efficiency. So therefore, fifth one is correct. Is that the answer in the scheme? I guessed fifth or second. Fifth one. Yeah. 55. The graph shows the variation of electric potential V with distance x in a certain region. The variation of force experienced by positive charge particle with x best represented by. So here we know electric field intensity is minus potential gradient. Okay. So here V is given voltage. So we can find the gradient and then we can find the E. Okay. And force equals F equals EQ. So these are the two equations that you require, or you can combine these two. F equals minus delta V over delta D times Q. So Q is constant, so you consider the negative gradient of this graph. So the first we can see initially the gradient is 0, therefore force will be 0. If there is no potential difference, the charge doesn't move. In order to charge to move, there should be a potential difference. That's why we use a battery. What we do from the battery, we take the low potential charge and put into a higher potential so that it will flow from the higher potential to low potential, like a water tank. වතුර ටික අරන් පැවැටේෂ potential උඩ වැඩි තැනක තිබ්බම උඩ ඉඳන් පල්ලෙහාට වතුර ටික ගෙනියන්න පුළුවන්. හරිද? So therefore, initially it has to be 0. Okay, every graph is 0, and then you have a negative gradient. The gradient of this is negative, means force is positive. So you have so you can ignore one and then gradient is constant, right? Here the gradient is constant, so force is constant. So therefore fifth one also we can remove. Okay, and then you have again 0 gradient for the same length. So therefore it is, now we have removed 1, 5. Okay, so again 2, 3, 4 accordance with that, and then we have positive gradient, lower gradient, positive lower gradient. So here positive gradient means this will be negative. So negative, the value is less, so the answer is second one. The force is less because the gradient is less, but it's negative. Second one, right? 56. A car travels at a speed of 20 meters per second towards a stationary sound source that produces a sound at frequency 1 kilohertz. Waves that are reflected from the car and return to the source are used to produce beats with the original waves. The approximate value of the beat frequency is okay. So here formula FB equals F times 1 minus V plus U over V minus U. I think, hold on. Dot V plus the already. Make beats, කෙලිම beats එක ගන්න. දර මේකෙන් මෙතන F එකක් එනවා මේකට F minus this one. Okay නේ? මට මේ doubt උඩ V plus U ද මේ උඩ යට හරිද? Check. Yeah, apparent frequency.
This one you observe.
Hold on. Yeah, let me derive that one. So here source is source going towards a rest observer. Travels at the speed of 20 meters per second. 20 meters per second. Okay. Sound source that produces sound at frequency 1 kilohertz. So if equals 1 kilohertz are reflected from the car and returns to the source are used. So here we have a car. Is the car is moving. The car travels a speed of 20 meters per second towards a stationary sound source. Okay, so I'll take this the car towards a stationary sound source. Speed of 20 meters per second. So the speed of the car u, that is equals to 20 meters per second. Towards a stationary sound source that produces a frequency of 1 kilohertz equals 1 kilohertz. Waves that are reflected from the car and return to the sound source are used to produce peaks. So we want to find the f. So when the car is comes here, let's find here f dash. F dash is equals to f times sound may. So observer related to observer is v plus u over the speed of related to source v. Okay, so this is equation 1, and then here reflected sound comes here f double dash, so that f double dash is equals to f dash times method relative to the observer v over relative to the source v minus u. Yeah, I think it's correct. Yes. So this is 2. There among combining, I want to get f double dash. Double dash is equals to f dash is f times v plus u over v minus u, f dash times, sorry, v, and here v over v minus u. This and this cancel. So f dash is f times v plus u over v minus u. So then the beats will be b is equals to f minus f double dash here v plus u, v minus u, dividing by a small number, this greater than 1, so therefore f double dash is greater than f, right? Actually we have to take, it doesn't matter actually, because we only take the okay, f double dash minus f. F double dash is v plus u, f times v plus u over v minus u minus f. So we have f common, we take out, it will be v plus u over v minus u minus 1. Okay. If you want, you can simplify this further as well. So v minus u, v plus u minus v plus u. And cancel, equals 2fu. 2fu over v minus u is the fd. Okay. Okay, so this is f double dash minus f. If I take in case f minus f double dash, if I simplify this, so if b is equals to v minus u minus v plus u divided by, so again we have, sorry, here minus u into f, same thing only I get f b equals plus v minus v cancel minus 2f u over v minus u. So anyway, we get this 2fu over v minus u. You can keep this for such case. Okay, you can write in as a short note. So sound එකක් ගිහිලා source එකක් ගිහිලා moving observer එකට වැදිලා ආයි මෙතනට ආවනම් ඒකට එන beat frequency එක මේකෙන් ගන්න. හරිද? Now my intuition says, now suppose and suppose මේ කාර් එක වෙනුවට make a, for example, a wall at rest. Now the source is moving this direction with 20 meters per second. Then I guess the same formula will come. I guess my intuition. මේ කාර් එක වෙනුවට මෙතන wall එකක්. හරිද? But this time this is moving this direction. Okay, then I guess the same formula will come. Can you do the max and get the formula, the beat frequency? Yeah, now instead of the car මෙතන rest make a wall එකක්. Now the source is moving, then the beat එක මෙතනින්ම source එකත් එක්කමනේ තියෙන්නේ. Source is moving, then what you get the beat frequency, what the expression will be. I guess same thing will come. It's my intuition, I'm not sure. You have to do it and see. එතකොට අපිට එතකොට either case වලට suppose මේ formula එනවනම් ඒ අවස්ථා දෙකටම මේක තමයි කියලා ගන්න පුළුවන්. කරලා බලන්න මොකද දෙන්නේ කියලා. අර ගන්නට උත්තර හොයලමුකෝ first. Okay, wait. So here we have FB is equals to 2 times F is 1 kilo means 1000 into U 20 over speed of sound in air is 320 minus 20. So therefore it will be 40 into 10 to the power 3 divided by 300. Make it 400 divided by 3. So 333.3. No. V minus U to F U. 1 kilohertz 1000. Okay. See 2 F U divided by V minus U. So 300. 400 divided by 3 is 133.6. So it will be a fifth one. Is it the answer in the scheme? No. Now source is moving with speed u, and here it is rest, a wall. Okay, and here you have to find the beat frequency here. මේ ගිහලා වැදිලා ආයි source එකට එනවනේ. එතකොට ඒකයි actual frequency දෙකේ beat frequency හොයන්න. You have to derive a formula. Getting the same thing, no? If dash is equals to observer v minus u f double dash what v plus u over observer v plus u c v relative to the source v f dash. So u v minus u f double dash. So f double dash is f. Suppose move relative to the observer v and v minus u. Okay. And this is we take f dash, this f double dash is equals to f dash. Okay. So then no, not like that. So here then f double dash you have to substitute v plus u over v times f dash is v over v minus u times f. Okay, and then is yeah. So no, no, there's they will from next week onwards there will be other classes. So okay, so here this is a sound, and here's the observer at rest. So the apparent frequency f dash will be f dash is equals to now this time it is related to observer v over source relative to the source v minus u. Okay. Now in Doppler equation, one thing that students confuse is උඩට එන්නේ relative to the source the observer. හරිද? ඒක මතක තියාගන්න හොඳම ක්‍රමය ඇවිල්ලා උඩ ඇවිල්ලා always observer. O starting from O over. Right? It is always observer comes to over the line. So in the උඩ ඉන්නේ observer පල්ලෙහා source. හරිද? So then this reflected will be heard by someone here. This double dash. So f double dash is equals to this f dash times the velocity of the sound relative to our observer. So sound is coming this direction, this moving this direction, v plus u. V plus u over relative to the source, it will be v. So therefore, f double dash is equals to f dash is this f times v over v minus u times v plus u over v and v cancel. F double dash we get the same apparent frequency v f times v plus u over v minus u. Okay. So therefore the beat frequency also, if you do the max, you will get the same. If b is equals to 2fu over v minus u. Okay. Because you got the same apparent frequency over here. So you get the same beat frequency 2fu over v minus u. So you can now onwards remember that either the case the apparent the beat frequency is given by 2fu over v minus u. Okay. Now there is instruments we can use this beat frequency phenomena to get the speed. For example, මොකද්ද මේ car වල speed එක we can use this. If there is no beats, means what will happen? The velocity of this observer is velocity of this object is moving with the speed of sound. Okay. All right. So the next question, 57. A particle is moving in a circle with constant speed v, as shown in the figure. The magnitude of the change in velocity of the particle between points P and Q. So this is actually a geometric question or a geometry. We just want to find the angle between them. And the answer will be 2v sine 20 if I'm correct. Let me check. So if I mark like that, it will be difficult for me to measure the angles. So therefore, I take, anyhow, I want to take the difference between the velocities. So I take one is here, okay, so that I can easily mark here. This one is velocity, this direction, okay. And then other component, I will take angle 40 degrees. Okay, so these are not actually 40. Okay, this is more than 40, like 45. But to just we want to get the angle, so I'm just mark like that. Make a tangential vector, make a V. So we know this is perpendicular, right? It's perpendicular. Okay. So now actually I want the angle between these two. So this one is in this direction, V, and so I want to find the angle between the vertical. I want to find this angle. So if I consider this 90, so therefore this will be 50. Okay, so then if I extend this, there this will be 50. So therefore this will be 40 because it's a perpendicular 40. So make other cone 40. Is that correct? කොටයි න මම ඒක මට එහෙම තිබ්බොත් ඉලස්ට්‍රේට් කරන්න අමාරු හින්දා මම ඒක rotate කරා so that this axis will be like this. Anyhow, we want to take the difference. So difference doesn't matter either if here or there. Okay. So again, this is V, and then the angle between these two 40, and so here extend this line and this line. This is 40 means, okay, this angle will be 50. So make up 50, so make up 40. Is that right? Okay, so this angle is 40. Okay, so VV. If we want to find the resultant of these two, the R is actually, that means, let's say vector V is V plus V, the addition is equals to 2V plus 20. The addition of these two, but there is a addition subtraction of these two vectors, okay, is equals to 2V sine 20. I'll explain the answers to third one. I'll explain you that. Now, if you have two vectors P and T making angle theta, the resultant will is equals to This is the resultant. Resultant is bisects the angle because both have the same magnitude. So theta over 2, theta over 2. So you can draw a perpendicular line for this resultant line. So then you can resolve this into two components. Towards the angle, p cos theta over 2. In this side, p sine theta over 2. And then this one, again this side, p sine theta over 2. This side in the same direction, so only we can add the normal addition, theta over 2. So this one equal and opposite cancels. So the resultant is r equals 2p cos theta over 2. I guess this formula you already familiar with, isn't it? No, you should know. If you have two forces, for example, 20 Newton, 20 Newton, making angle 60. So the resultant we can find r equals to 2 into 20 into cos of the half of the angle cos 30. So 40 into cos 30 root 3 over 2. So 20 root 3 Newton is the this you should know. Now in this problem we want to find the difference. So the difference actually now I'll take these two vectors, let's say p and p. So making angle theta, then their resultant r, which is the sum of the two vectors, p vector plus p vector is equals to sum it is actually 2p resultant cos theta over 2. Now if you want to take the difference, let's say this vector a and this vector b. So this is r equals a plus b, a vector plus b vector. So this is equals to the p are the magnitude of the vectors, let's say, and so then it will be 2p cos theta over 2. Now if you want the difference, let's say a minus b q1, what you have to do? This is actually a minus b is a plus minus b vector. එතකොට මම a එහෙම තියලා හරිද? a vector එහෙම තියනවා. b vector එකේ දිශාව වෙනස් කරනවා. Change the direction to the other side. So this is now b. So the sum of this r, let's say new r dash. So r dash is equals to this minus b. Okay. A vector plus minus b vector. Okay. So since both have same magnitude p, then this will bisect the angle. So this angle is theta, therefore this angle will be 180 minus theta. So each angle will be 90 minus theta. So therefore for this system I can apply this theory. So r dash is equals to 2 into magnitude is p into cos of the half of the angle. 180 minus theta के भाग्य क्या है? 90 minus theta over 2. Sorry, this 180 minus theta. So I write 180 minus theta divided by 2 bhaga kone. So if the angle is theta here, you the bisect the resultant bisect theta over 2. So here magnitude is same. So the resultant bisects the angle, total angle 180 minus theta. So each angle will be 180 minus theta over 2. Okay. So therefore here we write cos 180 minus theta divided by 2. So r dash is equals to p cos 180 divided by 2 is 90 minus theta over cos 90 minus theta over 2 can is sin theta over 2, 2p sin theta over 2. So if we come to this problem, then we want the difference of these two. Therefore it will be 2 into magnitude v into sin මේ දෙක අතර කෝණය 40යි 40 දෙකෙන් බෙදුවා 40 divided by 2. So we have 2v sin 20 is the answer. By the way, these actually you study as a theory in the vectors, don't you? The result sum of equal magnitude, this, the difference of equal magnitudes will be this. That is actually the last topic in the vectors I normally do in my class. All right. By the way, this you can't directly apply in the essay paper, even though. Okay. So this is the difference between two vectors. Here's R dash equals A minus B. The minus B you can write as plus in minus B. Therefore, you take the opposite direction. So make a අනිත් පැත්තට අරන් ඒ දෙකේ result එක. දැන් මේ theory එක දන්න කෙනෙක්ට මෙන්න මේකේ මේ problem එක මේ කෝණය හොයන එක. You know this angle, so you can write the answer to it. Okay, the next one. So what the summary of that part is, here you have vector P and here vector P, okay, making angle theta, then its resultant R, okay. So let's say R, which is vector P plus P, that is equals to, let's say its magnitude. So the magnitude, so here R is equals to, let's say P vector plus P vector. So if you write R, vector magnitude is R, so R equals to 2P cos theta over 2. And then if you want to find the difference of these two vectors with equal magnitudes, let's say, so I take R1, this, then R, where R1 is the vector sum. R1 equals P plus P. Okay. And then if I take R2 vector as the difference between the two equal magnitudes, P minus P, okay, so both are in vector notation, so you can't subtract, make අඩු කළ බිඳු වෙන්නේ නැහැ, because this one also has specific direction, this one has another direction, but only the magnitudes are same. So therefore, anyway, so here we consider then R2, where is the R2 is the magnitude of R2, then that is equals to, I think it's better if I write P1 and P2, and P1 vector magnitude is equals to P2 vector magnitude is equals to P. Became a samprayuta samaya. So P1 vector, yeah, so it's both. So therefore R2 is the difference, then it will be the magnitude of that will be 2P sine theta over 2. The R1 to get this 2P cos theta over 2, then difference 2P sine theta over 2. Okay. This one will really helpful for you in MCQs to find the answers, because otherwise you have to use this formula. R squared is equals to P squared plus Q squared plus 2PQ cos theta. මේක දාලා simplify කරනවා අමතර steps තුනක් වෙලා අපරාධ. If you put Q equals P, you get this simplified. මේක Q සමාන P දාලා simplify කරගෙන ගියාම to get 2p cos theta. Okay. So therefore, okay. Question number 58. The furthest point of distinct vision of a long-sighted person is at infinity. The furthest point of a distinct vision of a long-sighted person is at infinity. That means the eye is healthy. It's a healthy eye. This person uses a magnifying lens to view close objects. Okay, so he can view far objects. This person uses a magnifying lens to view close objects. He finds that he can see clear magnified image on the object is held anywhere between 50 mm to 60 mm from the lens, out nowhere else. His least distance of distinct vision. The furthest point of a distinct vision of a long-sighted person is infinity. Okay. This person uses a magnifying lens to view close objects. He finds that he can see a clear magnified image of an object if it's held anywhere between 50 mm to 60 mm from the lens, out nowhere else. His least distance of vision. Okay, so he has far-sightedness or short-sightedness. Hmm? Far-sightedness, yeah, he has far-sightedness. That means can view far but not close. Okay, so far-sightedness, what is the correction we have to? Convex lens. Far-sightedness, far-sightedness. Okay, so we want far-sightedness can view far. Uh, far-sighted means can view far and ළඟ බලන්න දුර පේන. So it's far-sightedness. So far-sightedness. So ළඟ එන රේඛ දුරින් එන වගේ පේන්න ඕන. So silence. Here to come far. Okay. For short-sightedness, ළඟ පේනවා හැබැයි දුර පේන්නේ. For that, what is the correction? Concave lens with the this one. No, the focal length should be equals to no is equals to this one D. D eකට කියන්නේ මොකද? Is distance minimum distance of distinction. Okay. Okay. So then here, okay, person at infinity. This person uses magnifying lens to view close objects. He finds that he can see clear magnified images of an object if it's held anywhere between 50 mm to 60 mm. Okay, so the lens එක තිබ්බා නම් මෙතන ඉඳන් 50 mm is the object distance V. So the image distance has to be infinity, you know, right? So no. Magnifying lens to being, he finds that he can see clear magnified image of an object if it's held anywhere between 50 millimeters from the lens. Out now, whereas his least distance of distinct vision is. So here, farthest point is that. මේ ගාන හදලා තියෙනවා මට. in 15. Oh. Hmm. Long-sighted person is at infinity. Long-sighted means he can view far, can't view close. This person uses magnifying lens to view close objects. He finds that he can see a clear magnified image of an object if it's held anywhere between 50 millimeters, 60 millimeters from the lens. So he can view anything from this interval, in this range. Okay. Out nowhere else. His least distance of distinct vision is. So object is placed at 50 mm. Then I'm not getting it. I want some questions on this. Yeah. So what is the explanation for this, guys? කොහොමද මේක ආවේ? Oh. Okay. This least distance of distinct visions. Make it other than okay. So it's 50 millimeter. So it's 5 centimeter. All right. I will get get back to you with this later. මට මේක ක්ලික් කරන්න නැහැ. මේ lens වල touch වෙන්න. 59. As shown in the figure, a small beaker containing a piece of wood and piece of stone floats in water inside a large beaker. The density of the stone is larger than that of water, and the density of the piece of wood is smaller than that of water. Consider the following statements made about the height of the water level inside the large beaker. When the stone is taken out and dropped in water, H decreases. Stone එක අරන් එළියට දැම්ම නම් H එක අඩු වෙනවා. B. When the piece of wood is taken out from water, H remains unchanged. When the stone and the piece of wood are taken out, tied together, and then put in water, if they go to the bottom of the beaker, H will increase. Of the above statement, which one is true? When the stone is taken out and dropped in water, H decreases. එතකොට ඒක හරිනේ. A is true. A is true. Yeah. So imagine so the upthrust U equals V rho W G, and if it's in equilibrium, this is equals to the weight. So V rho W G equals to mg, G cancel. So here I'll take capital M for total weight. So V equals M times V into rho equals. So if this mass is large, so the large volume of water will displace. Okay. So the mass එක අඩු කරාම හරිද displaced amount of water will be less. Okay. Now since the stone is sink on the මේක අරන් මේකේ දැම්මකට මේක මොකද වෙන්නේ සම්පූර්ණයෙන්ම වතුර එනවනේ. ඒ කියන්නේ මෙයාගේ පරිමාව v sigma g මම හිතනවා v1 sigma g සමානයි v1 sigma g වැඩි අක්‍රස් එකට වඩා v1 rho g g and g insert making yeah just hold on the make මේකට දැම්ම v1 හරිද දැන් මේක අරන් මෙතනට දැම්ම කියලා අපිට වැඩි වෙන්නේ පොඩි පරිමාවක් v1 පරිමාවක් හරිද let's say this volume is v1 so the volume that displays will be v1 okay v1 but when this is here the මේක අරන් මෙතනට දැම්මකොට displace කරන volume එක මේ v1 volume එකට වඩා වැඩි හරිද initially consider only this thing is there would okay මෙයා ඇතුලේ මෙතනට තිබ්බනම් displace කරන water volume එක v1 මෙයාගේ volume එක v1 මේකේ volume වල displace කරන water volume එක v1 now if you take this input here now what happens now more water will be displaced because it can balance the weight දැන් මේක අර මෙතනට දැම්මම displace කරන පරිමාව වැඩි ඒක තේරෙනවද මේක මෙහෙ ඇතුලේ තියෙන මෙතනට දාලා displace කරන volume එක v1 මේක ඇතුලට දැම්මනම් මෙතනින් displace කරන additional volume එක මම කියන්නේ v2 කියලා v2 is greater than v1 can you understand that you can write I mean මේකට volume අරන් මේකට අරන් කරලා පෙන්වන්න පුළුවන් but it will take time you can show that this v2 will be greater than v1 okay okay if you are satisfied I'll try let's say this one is this entire thing as is something m naught and this one mass m1 and this one mass m2 okay and then we want the densities also it will be actually taken the thing is now if you can understand make a v1 එක අරන් මේ mass එක අරන් මේක දැම්ම නම් so additional volume එක displace කරනවානේ ඒ volume එක v2 නම් ඒ v2 එක මේ v1 වලට වැඩි can you understand that can you understood can you didn't get it now I can දාලා මේ values ඔක්කොම දාලා explain right it will be complicated we'll consider simplest case scenario I take this okay and let's say we have only a container okay a container and or so I consider a uniform rod okay a box okay and here we have this let's say this one mass is m2 and this one mass m1 right? And then displace volume let's say v this volume v1 and this volume v2 okay okay so first I can consider this equilibrium so m1 let's say this density is rho 1 and this density rho 2 so here mg equals m1g equals v1 rho g negative make equal so m1 equals v rho okay m1 is equals v2 so right so now I take this mass and keep on top of this okay then we have m1 plus m2 g equals Now the volume displaced is, let's say, V dash rho G. G and G cancel. So we have V dash M1 plus M2 equals to V dash. Okay. So now I want to find the total mass into this one. Yeah. So M1. So first only this object. So M1G equals volume is V1 rho G. Okay. So V1 rho. The thrust is equals to the weight. Okay. So we have M1G equals V1. And then now if I keep this mass here, then M1 plus M2G equals V dash rho G. So M1 plus M2 equals V dash rho. I take this equation 1 and this equation 2. Okay. So then I want the change in volume. That means V dash minus V1. V dash minus V. So V dash is equals to M1 plus M2 over rho minus V1. V dash minus V1. V1 is M1 over rho. Okay. M1 over rho. So if I simplify this, V dash minus V1. හරිනේද මේක M1 සමාන V1 rho, M1 plus 2 equals V dash rho. So V dash will be M1 plus M2 over rho, and V1 will be M1 over rho. So rho is common. So we have the difference M2 over rho. Okay. So therefore V dash. Sorry. Yeah. So from here I take V dash. V dash is M1 plus M2 over rho, and we have V1 is M1 over rho. So make a change in volume is V. This is delta V. ඒ කියන්නේ මෙයාව මේක උඩින් තිබ්බම වෙනස් වෙන පරිමාව. Okay. So that is delta V. Delta V equals M2 over rho. So I take this equation 3. From this I can the M2 M2 I want to consider M2 is equals to making ඇති වෙන පරිමාව V2 නම් මේකේ object එකේ density එක rho 2. So therefore M2 is actually equals to rho 2 times V2. Delta V equals M2 mass is rho 2 times V2. Rho 2 times V2 divided by rho. Okay. So therefore delta V is equals to rho 2 over rho times V2. So this is the change in volume. This is the volume of the object. එතකොට මේකේ you can see if the density is larger than water, okay, then this is a value greater than 1. එතකොට මේ වැඩි වෙන පරිමාව V2 වලට වඩා වැඩි. මේ පරිමාව සමාන වෙන්නේ මේ දෙන්නගේ density සමාන. So therefore මේ object එක අරන් මේක උඩින් තිබ්බ මොකද වෙන්නේ? Change in volume is greater than the volume of the object. Yeah, lesser. එතකොට අඩු නම් වාට මේක මේ පල්ලෙන් තියන්න බෑ තන්තුවකින් ගැට ගහලා තමයි තියන්න ඕනේ. ඒතකොට මේක හෙල්ලිලා තියෙන්නේ. එතකොට උඩින් තිබ්බනම් ඒතකොට ඩිස්ප්ලේස් කරන පරිමාව මේ වස්තුවේ පරිමාවට වඩා අඩුයි height එක. එතකොට මොකද වෙන්නේ මේකේ height එක. So මේකට මොකද වෙන්නේ? මේකේ delta V ඇවිල්ලා මේ V2 වලට වඩා වැඩි. මෙයා උඩින් තිබ්බම ඩිස්ප්ලේස් කරන පරිමාව මෙයාගේ පරිමාවට වඩා වැඩි හින්දා height එක increase වෙනවා. අරකේ අඩු හින්දා height එක අඩු වෙනවා. හරිද? Okay. If the density of these two are same, then height will remains unchanged. Okay. ඇයි මෙයාගේ පරිමාණය මේ පරිමාණය සමානයි. ඒ හින්දා height එක remains unchanged. Okay. So you can write this, make a label. If the densities are same, the height remains. Okay, where when the stone is taken out, dropped in out and dropped in water, h decreases. හරි. දැන් statement A එක මොනවද කියන්නේ? මෙයාව අරන් මෙහෙට දැම්මනම් h එක අඩුයි. ඒක හරිනේ. Statement A is true. When the piece of wood is taken out and put in water, h remains unchanged. Piece of wood is taken out and put in water, h remains unchanged. So that is wrong, no? B statement. That is correct. Yeah, because the wood, if the wood density is less than water, you see, then yeah, the wood will float in water, no? So therefore it will remains unchanged. හැබැයි ඒ wood එකම අරලා මෙහෙට පල්ලෙහාට තන්තුවකින් ගෙලගාලා තිබ්බා එතකොට h එක වැඩි වෙනවා. හරිද? එතකොට මේක h එක වතුර දැම්මම මොකද වෙන්නේ? පා වෙනවා. එතකොට මෙතන බරට සමාන දෙයක් නේ ආයෙත් මෙතන තියෙන්නේ. බරෙන් වෙනසක් වෙන්නේ නැහැ wood එකේ. ඒ හින්දා displace කරන volume එක සමානයි. The Archimedes principle. The weight is equal to displaced amount of volume. මෙතනත් තියෙනකොට එකම බරයි wood එකකින් කොට එකම බරයි wood එකකින්. Now if you totally submerge තන්තුවකින් ගෙලගැවුවා නම් height එක වැඩි වෙනවා. හරිද? ඒ displace කරපු volume එකට අමතරව තව volume එකක් මේ වතුර ඇතුළට යනවා. දැන් අපිට volume මේ වතුර displace amount එක නෝනේ. හරිද? දැන් මේකෙන් මෙහෙනකොට මේකෙන් ඇත්තටම පොඩි බරක් අඩු වෙනවා. ඒකට බරක් අඩු වෙනකොට volume ප්‍රමාණයක් අඩු වෙනවා. displace කරනවා. ඒ ප්‍රමාණය ආයේ මෙයා මෙතනට දානකොට ආයේ displace වෙනවා. ඒ ප්‍රමාණයම ආයේ displace වෙනවා. හරිද? So A is A අපි මොනවද කිව්වේ? True or wrong? When the stone is taken out and dropped in water, h decreases. යාර මෙහෙර දැම්ම නම් h වැඩි වෙනවා. යාර මෙහෙර දැම්ම නම් h අඩු වෙනවා. So A is true, no? B is true. When the stone and the piece of wood are taken out, tied together, and then put in water, if they go to the bottom of the beaker, h will increase. Yeah, that is also true. C is not true. Only A and B is true is the correct answer. When the stone and the piece of wood are taken out, stone and piece of wood taken out, tied together, put in water. They go to the bottom of the beaker, it will increase. මේ දෙකම අරන් එළියට දැම්මම මොනවද වෙන්නේ? දැන් obviously මෙයා මෙහෙට එනකොට පොඩි වෙනසක් තියෙනවා. volume difference will be there. මෙයා ඇතුළට ආව නම් අමතර volume එකක් යනවා. Statement C. When the stone and the piece of wood are taken out, tied together, and then put in water. If they go to the bottom of the beaker, H will increase. They go to the bottom of the beaker. They go to the bottom. So you have only be tight and put down. මේ වොලියුම් එක විතරයි තියෙන්නේ. හරිද? එතකොට මෙතන මේක නිසා මේකේ සම්පූර්ණ වොලියුම් එක V නම් එතකොට මේක මෙතන තියෙන කොටත් ඩිස්ප්ලේස් කරපු වොලියුම් එක මේ දෙක නිසා ඩිස්ප්ලේස් කරපු වොලියුම් එක V වෙන්න ඕනේ. That's all. Oh, it is decreasing. H will increase. It says it increases. So I think the correct statement is when the stone and the piece of wood are taken out, tied together and put in water, if they go bottom of the beaker, H will decrease. Yeah, the correct statement is window. You can think similar to the A. Yeah. But still the delta V is 0. I mean delta V is of the delta V of the this one, if you consider that is greater than the this no, one. Still delta V is yeah. Then one lesser than V2. Okay, fine. Greater than one. No, make you can't consider for the මේ equation එක ඔයා මේකට දාන්නද rod එකට wood එකට because it's because here V dash minus m1 row. Yeah, if you tie it both together, then you can think of the effective density. Okay, so you can consider the effective density of that. Okay, so the effective density is again greater than yeah, so the effective density is if it's sinking means yeah, correct. Harini, the effective density is greater than water නේ. එතකොට මේ ඒ හින්දානේ එයා පල්ලෙහා ඉන්නේ. හරිද? එයා පල්ලෙහා ඉන්නවා කියන්නේ effective density එක මේ වතුරේ density වලට වැඩි. ඒ හින්දා you can consider the same scenario as A. It has to decrease. The C statement හරි වෙන්නේ H will decrease. H will decrease. All three is correct. Since it has mentioned H will increase, so only A and B is true. Okay. Okay. 60th. Last question. The semicircular conductor PQR having a uniform cross-section area is placed vertically in a horizontal uniform magnetic field as shown in the figure. A conducting rod OA pivoted at the center O of the semicircular conductor rotates with a constant angular speed about a horizontal axis passing through O parallel to the magnetic field. PQR OA are made of material of the same resistance. An ammeter is connected to the two ends O and R if the ends A touches PQR. If end A touches PQR, the variation of EMF E induced across OA and the current I throw the ammeter with the time t are best represented by pair of graphs. So we want to induce EMF and current variation when this OA rotates with constant angular speed. So we know definitely when the contact, if there is no contact, okay, will there be a current? No. So therefore current should have, okay, so all graphs are like that only current. Okay. And so the Faraday's law, what is induced EMF? E equals the rate of change of delta psi over delta t. Okay, the flux, number of flux intersecting the within delta t time is the delta psi. So here for a rod we have the formula. No, what is that? Half rod induced EMF. The formula. There's a formula. Give me a second. So the formula is E equals half d omega r square d omega r square. Okay. Can't you come up with this formula? Okay, so here it's like this. Hmm? Source book, okay, I don't think we have this actual application of E equals BLV. Right? So we know E equals BLV, but if you take a rod rotating in a circle, රොඩ් එකක් තියෙනවා. එතකොට මෙතන ස්පීඩ් එක 0යි, මෙතන ස්පීඩ් එක v. හරිද? Okay, so this speed is given by r omega, but you can see gradually here the velocity is 0 and it is increasing. each point, each value has a different velocity. So actually you have to integrate to get the effective value. But in physics, we use the result as we taking the average of this point and this point. Okay, so E equals BLV. The V is velocity is changing every point. Yeah, in a magnetic field rotate. So radius is R. So E equals D. The length is now radius R. Okay, and V is we take the average 0 plus R omega over 2. So we get E equals half d omega r square. Okay, so that is the EMF. Okay. Wave condition. Parallel to the magnetic figure over material with okay. So here the induced EMF is given by constant. I is constant. Induced EMF is constant. So all have flat. Okay. So we have 1, 2, 3, 4, 5. Make a one in I make a contact when the contact is not there won't be a current. There won't be in this here. So therefore one won't come. So we have either 2, 3. 2 is also not there. I'll explain why. 3, 4 is also not there. So either 3 or 5, 4 and 5. So the answer is third one. Hmm? 1. Hold on. Yeah. Because to have an induced EMF, it not necessary to contact. Even there is no this BO, this POQ, rod. Yeah, if you have just a rod and if you rotate, that's enough to maintain a induced EMF between these two. So yeah, so the answer is 1. Okay, for the I, because as you pass through this, the length එක වැඩි වෙනවා. මේක contact මේක rotate වෙනකොට contact වෙලා තියෙන length එක වැඩි වෙනවානේ, current එක pass වෙන length එක වැඩි වෙනවා. The length that current pass is increasing, as length increasing, resistance increasing. So as a result, current goes down. Understood? Now here. Now E is constant. That means the induced EMF is constant. E is this material. Now, if we contact here, only current will pass through this length. Total length එක මෙච්චරයි. Additional. මෙතන contact කරනකොට අමතර තව දිගක් නිසා length එක වැඩි වෙන හින්දා resistance එක වැඩි වෙනවා. Just R equals rho L over A. As L increases, resistance increases. As result, current decreases in this each. Yeah. And then after the contact is not there, the current will be 0. Is that clear? Okay. All right. Okay, so let's conclude the class from here. Okay, you also not feeling well, and others didn't. You did the paper, no, that shared one, but he hasn't done the paper, it seems, and so let's conclude half an hour earlier. Okay. Next week, then that paper only we have to do. But then again, I will put another paper. Or we can do the structure of it. What shall we do in coming week? Or I put another MCQ paper or any model paper. And next week, anyway, we will be discussing that MCQs. But then again, you have to do work. Or else this week you can have other works. You can spend time on other works. So we'll next week we'll discuss that MCQ. Okay.